Yeah, so here we want to go over some of those exercises from your section 7.7. So we're dealing with sectors. Let's get a pencil working here, okay? We're dealing with sectors of a circle. Now, what is a sector? Just what you see, a slice of pie, slice of pie. And what is the area formula for the sector? It's a fractional part of the total area. So it's the central angle divided by 360, that's the fractional part, times pi r squared. Okay? So if you look at this guy, any one of them, it's, all right, let's look at number 9 here. Since this angle is 120, and this is a diameter, that would mean my angle here is 60. Okay, that's 60. And so what I want is 60 over 360, that's 1/6 of the total area, and the area is pi r squared. R is 13 since the diameter is 26, so it's 13 squared, so it's 169 pi. So basically that's going to come down to this going down to 1/6, so it's actually 169 pi over 6, and that's just fine to leave it that way. Okay? The rest are going to be just as straightforward, just using the formula right up here. This, of course, is asking for everything but that slice. So 45 is what we're looking for is 45 breaks it up into eighths. So we're looking for 7/8 of the pi r squared of 8 squared pi, right? So that cancels out real nicely because you get 64 pi times 7/8. Okay, and so that would go in there. 8 times 7 is 42 pi would be the area in question for everything involved in here. Okay, so these are asking you to do more of the same. Okay, the only thing is you don't have the figure. You have the angle, you have the radius, you have what you need to find the area by the angle over 360 times pi r squared. So you have everything you need there, so it won't be a big problem. Okay. All right, these are in here, we're trying to find the segment. Remember, this is what's called the segment of the circle. And remember, we went through Sketchpad and showed you that the segment of the circle, you have to find first the sector, and then you've got to subtract out the area of the triangle. Okay, so we'll take a look at number 17 here. Okay, so we realize that that angle there is 120. So in terms of the sector would be 120 over 360. So that would be 1/3 of the pi r squared. So that would be 1/3 of 36 pi. Now that would, of course, be this whole area in here, right? That would be that whole area in there. But so that's the sector is 12 pi. Okay, so now we're going to come back and we have to find that triangle. So what's that triangle? Well, as you can see, that triangle has a 120-degree angle in there. So lo and behold, we're going to separate that into a 30, 60, 90. Okay, looks a little crowded there. Let's blow that up a little bit. So here's my 30, and my side here is 6. Okay, which is the hypotenuse. So the side opposite that would be half that, which would be 3. And okay, so we're back, and we're going to look at this triangle in here. So the hypotenuse is the radius, that's 6. This is the short side, which is 3. This side would be 3 root 3 from the 30, 60, 90. The area of the triangle would therefore be 1/2 the height, which we just found here is 3. Oh, 1/2 the height. 3 times the base. Now remember, the base is the base of the whole thing here. Half of it is 3√3. So the whole base is 6√3, which gives us that area equaling 9√3. So the area in the shaded region here, that's the segment of the circle, right, is that area of the triangle sector, which we found was 12 pi rather. So the area for that problem is 12 pi rather, 1/3 of 36 pi, 12 pi minus 9√3. And that's exactly how we're going to leave that answer. The others would be found the same way here. This is a 60-degree arc, and of course this is the region that we're after, just that little bit. So it would be 1/6 of the entire circle area minus the area of this, which would be an equilateral triangle of side 6. So you need to go blow that up a little bit. The sides are 6. Then you'd need to find this height here. That's this. That would be that height right there, which you should know your 30, 60, 90 and figure that out. Maybe that would be your 30 or your 60, so that should be 3√3 if you check that, okay? Here's the same thing. I wouldn't say nearest tenth, I just say leave pi in terms of pi. Okay, the only thing is you don't have the benefit of the picture, so you might just want to, this picture would be related to number 17, with except the radius is larger but the arc is the same. This picture would be related to number 19 with just a different radius, okay? The same thing here. Now here, what they want is they want you to find everything but that region. Everything but that region. So, so you got the entire area of the circle. Let's do this number 22. The area of the circle is pi r squared, so it's 18 squared times pi, so that's 324 minus that little cap region there, which is what? That's 90 over 360. It's a fractional part of the entire area, so that's what? It's 1/4 of that entire area, which we just found was 324, less the area of the triangle, which is 1/2 of, it's a right triangle, so it's 1/2 the product of the legs, which is 1/2 of 18 squared, okay, which is 1/2 of 18 squared. 18 squared. Now, I'm sorry, this should have been 324 pi. It's pi r squared, so that's 324 pi. Put that in there. 324 pi minus 1/4 of 324 pi. 324 pi. Okay. Minus 1/2 of 324. Okay, so that's what you would do to find that area right there. Okay, compute all this and take it away from 324 pi, and the others would be in the same way. These you have to think about. Okay, not so bad here. Okay, in fact, this is really the same thing as this. Okay, it's the area of the square minus the circle, and this, of course, is just rearranged. If you just split that square down the middle and shifted these halves, that's what this would give you. And now this is the same thing actually, okay? Because here, this area is what we're after. So this area is the area of the square less 4/4 of a circle. So So this area is going to be the square minus the circle, which is going to be the same thing as this. These all are found in the same way, even though they look different. They're all going to be found in the square minus the circle. And the last couple, some things for you to think about. Of course, this goes back to the hexagon, so this would just be the circle minus the hexagon. And of course, that would just be 1/2 the apothem times the perimeter for the area of the hexagon. This is, okay, requiring, these two will require a little bit of thought, okay? But what you want to do is, suggestion is, what you do is you split that down the middle. And what you can see is that this portion right here, let me see if I can color that in it a little bit. That portion is actually the segment of the circle. So that portion is like one of these problems we did up here earlier. Okay, it's just like this. It's just like that portion of the circle right there. It's a quarter of the circle segment. Okay, much like this right here. Same thing as number 18. So that problem is going to go back to that, and you're going to see that that's actually what the green area is. So if you double that, then that will find that the area in white, and if you subtract that from the entire square, you'll find the shaded area there. And this I'm going to let you think about this one, okay? But you know, you can reason out that since the largest circle has a radius of 4, each of these smaller circles have a radius of 2. Okay, and you just got to think about what is the total amount of area that is represented in this shaded region. Okay, and I'm going to let you think about that for a little bit, but it's actually, I'm going to make a suggestion to you is that you split this in half and see about placing some of those portions over here. In other words, if you split that down in half and you take this section here, that'll plug up a half a circle over here. So the only thing you have is a half a circle plus, okay, well, that might actually do it for you. Think about it, okay? So I'm not saying anything more. You can figure it out, okay? Something for you to think about. There you go. There's your segments of the circle as fractional parts. Sectors first. Sectors as the fractional part of the entire area, slice of pie, and then the segments as the slice of pie less a triangle. So again, you're looking for those special right triangles in there. You know, they'll make you think a little bit, but they're not impossible. So have some fun in doing them, and we'll work on them in class as well. Okay, there you have it.